Hello dear students, we continue with exercise 4.3, sum number 17 to 16. The sixth one we had finished in the previous video. 17, seventh one sum. Again, the question is the same one what we had done previously. That was find the inverse of each of the matrix if it exists. Okay. So we have to find the inverse of each. Now I had told you last time for every matrix to have inverse should exist. For that we have to take the determinant and find out the value of determinant of the matrix. So if you take 1, first row, first column eliminate, whatever remains write it in determinant form and then cross multiply. So this is how you get the value of determinant, and if it is not equal to 0 then A inverse exists. If it is equal to 0, A inverse does not exist. After we find the determinant, we move on to the next factor, that is finding the cofactor of each element. Here the cofactor of each of the element is being found out. I told you one more thing here, that cofactor you can find out only if you know the minor. So to find cofactor you have to find the minor first. Now minor is actually this much determinant, and cofactor, if you remember, I had told you this is the easiest method to find out cofactor. Take the determinant of the remaining part, like first row first column. If A11 is there, take first row first column, take the determinant of that first row first column, and this is 1 1, so we write minus 1 raised to 1 plus 1, so it becomes plus 1, so it is plus 1. So if it is an even number, directly take plus sign. If it is an odd number, directly take minus sign. Okay, so this is how it goes, and these are the cofactors, and this is a adjoint of A. Adjoint of A is determinant of cofactors and its transpose. So transpose is, I have marked over here, this is a transpose, so this is your adjoint of A. And formula to find A inverse is 1 upon determinant A into adjoint of A equal to 1 upon this determinant A was 10 into adjoint of A is this matrix, this one. So this becomes the inverse of this matrix. Okay. Then question number 8, same way. I have done here. First find out determinant A, it is not equal to 0, it is minus 3. Then find all the cofactors. Cofactors are found out here. So children, you have to work it out on your own. Okay. Then adjoint of A. Adjoint of A's transpose is here. And this uh, transpose matrix is written. Then A inverse is 1 upon mod A. Adjoint of A equal to minus 1 upon 3 and adjoint of A. Okay. Here it should be multiplication sign, so please make that correction. I just try to make here multiplication sign. Okay. Please make that correction, children. Okay. Next, ninth sum, again same. You have to first find whether its determinant A is equal to 0. Once you find out that it's not equal to 0, it's again equal to minus 3, find the cofactors, and then this is your A inverse. Okay, these all sums actually I was going to give you for homework, but it is there, so I'm sending you in this video. Anyway, how to solve it I have already explained you, so these you have to practice on your own. Question number 10, again same way. Find determinant A, it is not equal to 0, so A inverse exists. Find all the cofactors, then find adjoint of A, that is transpose of cofactors, then write it in the transpose form. So A inverse is 1 upon mod A, adjoint of A is minus 1 upon 1, and these are the matrices. Okay, so this is the inverse of matrix. Then next, question number 11 also same way we have to question number 5 to 11, same procedure is there. So here A, we first find out determinant A, which is not equal to 0, therefore A inverse exists, and then thereafter we just solve the sum by finding cofactors. Find the cofactors. Here are the cofactors of every element. Write the determinant of cofactors, take its transpose, that will become adjoint A, substitute it in the formula, and this is your A inverse. Then question number 12 is, let A is equal to, this is matrix 3, 7, 2, 5 and B is 6, 8, 7, 9, and verify AB inverse, that is B equal to B inverse into A inverse. Now this inverse you can find out using adjoint method. So what we can do is matrix A is here. So we have to first find AB inverse. So for this we should know that their inverse exists. So first we see whether A inverse exists. So when we take determinant A 3 5 is a 15, 7 to the 14, this is 1 not equal to 0. That means A inverse will exist. And A inverse is 1 upon mod A adjoint of A. So this simple it is, because it is a 2 by 2 matrix. It is simple. And then B, if we take B, and we see that its determinant is equal to -2, which is not equal to 0, therefore B inverse exists. So 1 upon mod B is into adjoint of B. Again adjoint of B, children, transpose of cofactor matrix. So this is the transpose of cofactor matrix. It is written over here. Now here AB is equal to this into this matrix A into B. Actually you multiply and you get this matrix AB. Now AB we have to find its inverse. So again here AB we check whether its determinant is 0 or no. So it is not equal to 0. So again AB inverse exists. Then AB inverse is 1 upon mod AB into adjoint of AB. So this is AB bracket inverse. This is first one. Now we find out B inverse into A inverse. B inverse already we have found out here, and A inverse also already we have found out here. So B inverse is here and A inverse is here. It actually multiplied, and then this is what you get. And from this and this you see equation 1 and 2 is equal. Therefore LH is equal to RHS. 13th sum, if A is 3, 1, minus 1, 2. Show that A square minus 5A plus 7I equal to 0. You have to find A inverse. Okay, you have to show this first and then you have to find A inverse also. Such kind of sum comes for 4 marks in the board exam. So just see, we have A first. This is A. We find A square. This type of sum we have done in matrices also. Then after finding A square, this is A square matrix, we substitute in this equation A square minus 5A plus 5I. When you substitute in this, you will be getting it is equal to 0. So this is all equal to 0. Now what do you do in this same equation? We multiplied by A inverse. So A square, A inverse minus 5A, A inverse 7I square, I2, A inverse equal to 0 into A inverse. Now 0 into anything is 0. A square into A inverse. Now this is A into A inverse. Now A into A inverse. A into A inverse can be written as I, and A will remain. And 5I again, and 7 here A inverse. Okay. Now this is 7 A inverse is here. 7 A inverse is minus A plus 5I. We just do the same thing. So multiply this equation by -1. This is minus A plus 5 into I. Okay, so that will be, this is the equation. So this will become your A inverse by simplifying. Next question is, for the matrix A, find numbers A and B such that A square is small a capital A plus BI equal to 0. Now A is this matrix. We first find out A square matrix. Here A square is this. We got 11, 8, 4, 3. Then we have A square plus AI plus BI. BI2. So this values we substitute here. After substituting the values, you get it equal to, this you equate it to 0, 0. Now you see every equation here, 11 plus 3a plus b equal to 0. It's written here. Then 8 plus 2a plus 0 equal to 0. It's written here. When we simplify this, you get 2a equal to -8. So a is -4. A is -4, you can substitute in this equation or any other equation. This third one you see 4 plus A equal to 0. There also if you substitute, you get A is equal to -4. Okay. then that means A is minus 4 value is correct. Now substitute in any of the other equations and get value of B. Then 15th one, for this matrix A, show that A cube minus 6A square plus 5A plus 11I is 0, and you have to find A inverse. So again here, same way what we do first, A cube we find out. A cube is here, this is A cube. But first multiply, find A square, then find A cube, and then after finding A cube, just substitute in this equation. So this is substituted in this equation, and this sum is very long, children, and this is the reason why I chose this way to send you videos, because it's impossible for me to write these big sums on the board. So this is equal to 0. Next, you find A inverse. Now from this equation only, multiply again, like how we did in the previous example. Multiply by A inverse, you get this equation. When you get this equation, you get 11A inverse equal to 6 minus 5I minus A square. 11A inverse equal to 6 in this equation's value you substitute. Then after substituting the value, you get 11A inverse this value, and A inverse will be 1 upon 11 in this value. This is how you. Same way 16th one is also very long sum. First find A square and then find A cube. Once you find A cube, substitute the value in the given equation and equate it to 0, 0, 0. Now from this only, what we do, again multiply this equation by A inverse. When you multiply this equation by A inverse, you get this. So you get 4A inverse equal to remaining terms. And these terms values you substitute, you get A inverse. Try out the sums on your own. If you have any doubts, kindly contact